Alright, so now let's take a look at a quick review of trigonometric functions, everything you need to know. So radian measure comes important because especially in BC, in BC we need to learn how to find the length of, in this case, the length of that arc, which would be this, and let's call the length of the arc S. Okay, because later on, in some of the stuff that we do in BC, we'll refer to it as S as well. So let's just stay consistent there. So that's the length of the arc. And let's find that arc length. So the arc length is pretty easy to find. The equation for that is arc length is just radius times theta. So in this case, the radius is 3 and your theta measure, so angle measure, so that's in radian, is 2 pi over 3, and those 3's will cancel, giving you just 2 pi. So then that gives you this exact length of that arc. And all you need is the angle in radian and your radius, and that gives you the exact length of that outside, or the crust of that pi. Now, just reviewing really quick, write these down. I'm not going to spend too much time with them, but you have sine, cosine, tangent, cosecant, secant, cotangent, and all of these are the ratios of those respective properties. Just be familiar with them. Just be familiar with them and how to use them. And you know, if you're familiar with right triangle trig, this is where all of them come from, where this is x, that's y, and this is r, and in here this is our theta that we're working from. So you can use SOHCAHTOA to get any of these. Okay, so graphs of trigonometric functions, we are going to be doing one example, but all of them can be found in the book somewhere around page 47, but we're going to be doing one example of them, so let's take a look at them. So first of all, the period of the function is basically how often a function repeats. We can also find the period of a function it's going to be in this equation, 2 pi over b. Okay, and this is your b part right here. Okay, so, even and odd, so cosine is even, secant is even, all of the other ones are all odd. If you look at the graph, you can tell which ones are in fact even and which ones are in fact odd. And I would probably sketch these 6 trigonometric graphs on your toolkit, make them pretty small, but put them on your toolkit so you can glance at them quickly if you needed to. So first of all, just this equation we're going to use on this example, but A represents the vertical stretch or shrink, and if it's negative it reflects around the x. Horizontal stretch or shrink is determined by the B part, and again that's what we use to find the period, because if it's shrinking or stretching horizontally, then that's going to affect how often it repeats. Makes sense. And on average, you would take the regular 2 pi if it repeats every 2 pi. You know, some functions are every pi. You just have to be familiar with which ones have a period of pi, which one, like tangent, would have a period of pi. Most other functions would have a period of 2 pi, and just divide that by b, and that tells you this period. And then also C tells you the horizontal shift, and then D tells you the vertical shift. So let's go ahead and try this example. Determine the period, the domain, range, and then draw a graph of the function. So first of all, if you look at this, it's cosecant. If you look at the graph of cosecant, what it looks like, you can go ahead and try to alter that graph to match what's going on here. So just to get you started before you do that, to make it look like that equation that we just saw, what we have to do is just get this so it's x by itself. So factor that 3 out, that becomes the b. Then you would have the x plus pi over 3 minus 2. That way it mimics that equation that we looked at on the previous page here. Okay, so from here you have your a, b, c, d. Go ahead and try to sketch a graph of the function, then come back and see how you did. Okay, so you should have found that the period, your b is 3, so the period occurs every 2 pi over 3 units. And then your domain, in this case, here it takes the regular graph and pushes it over pi over 3 units. And so if we look at our graph here, instead of everything being perfectly lined up, what it does is every pi over 3 units, so you'd have pi over 3, 2 pi over 3, and so forth. That's how often, first of all, that's your period. Okay, from 0 to 2 pi over 3 is your period. And so then that means pi over 3 is halfway between, and so then that's where it's cut in half. So anyway, x cannot be 0, pi over 3, 2 pi over 3, or any pi over 3 times any constant. So then that would be your domain, or you would define the domain by what x cannot be. And then the range are, okay, so x cannot be 0, and then any plus or minus k pi over 3. And then your range, so here's the interesting part. Okay, you notice that with the range, you go -2, but then also this 3, the amplitude, what that would do normally is push this from 1 to 3 and then from -1 to 3, but then also at the same time you're shifting this graph down too. And so then that means your range goes from -5 to -infinity, and then that's unioned with 1 to infinity, and that becomes your range. And then draw a graph of the function. Hopefully your graph looks something like this. I know cosecant's kind of not used all that often. Just be familiar with what the graph looks like and how to maneuver it to, or how to move it around on the coordinate plane. Okay, so we reviewed trigonometric functions. Again, be familiar with this equation, really important. Definitely want to highlight that. Now, mostly what we do with these functions in terms of calculus is understand what the graph's going to look like, be able to find derivatives of them. So it's not a deep understanding like what you needed in pre-calc, but hopefully your pre-calc was enough that gets you through what you need for this. Okay, and then that's it. All we needed for trigonometric functions.